LLM versus traditional systems. Hello, everyone. Today, I'd like to walk through the difference between LLM systems and traditional systems. This is an important topic because LLMs are powerful, but they are not a replacement for every system. Traditional systems are good at deterministic logic. LLM systems are good at understanding and generating language. So the key question is this: when should we use traditional systems? When should we use LLMs? And when should we combine both? Now, let's start with the core framework. When I compare LLM systems with traditional systems, I usually look at 5 dimensions. First, determinism versus probabilistic behavior. Second, control versus flexibility. Third, problem suitability. Fourth, reliability, debugging, and cost. And finally, hybrid architecture. The main trade-off is precision versus generalization. Traditional systems give us precision and control. LLM systems give us flexibility and generalization. Let's start with traditional systems. Traditional systems are rule-based or algorithm-based systems. Examples include back-end services, APIs, SQL queries, business logic engines, rule engines, and deterministic pipelines. The flow is simple. Input goes through explicit logic. Then, the system returns an output. The main characteristic is determinism. Given the same input, the system should always produce the same output. For example, if a user clicks Cancel Order, the backend checks business rules, validates permissions, updates the database, and returns a predictable result. This makes traditional systems easier to test, debug, and reason about. They are best for tasks that require strong correctness guarantees, such as transactions, authentication, authorization, payment logic, financial calculations, and business rules. The key idea is this: traditional systems are best when correctness and predictability matter most. Now let's look at LLM systems. LLM systems are probabilistic systems built around language models. The flow looks like this. Input goes into a prompt. The prompt includes context. Then the request goes to the LLM. Finally, the LLM generates output. Unlike traditional systems, an LLM does not follow explicit business logic line by line. It generates outputs based on learned patterns, prompt instructions, and runtime context. This makes LLM systems flexible. They are good at natural language understanding, summarization, question answering, classification, code generation, explanation, and ambiguous tasks. For example, if a user says, "I want to return something I bought last week," a traditional system may need strict input fields. But an LLM can understand the user's intent, extract key information, and ask follow-up questions if needed. The trade-off is that LLMs are less predictable. They may hallucinate, misunderstand context, or produce inconsistent output. The key idea is this: LLM systems are best when the task is language-based, ambiguous, or unstructured. The biggest difference is determinism. In traditional systems, the same input should produce the same output. In LLM systems, the same input may produce a different output. This is not always bad. For creative writing, summarization, explanation, or open-ended tasks, flexibility is useful. But for correctness-critical workflows, this can be dangerous. For example, we do not want an LLM to directly decide whether money should be transferred, whether access should be granted, or whether a transaction should be committed. Those decisions should stay in deterministic systems. So, the trade-off is this: traditional systems provide control. LLM systems provide flexibility. Reliability is also different. Traditional systems fail because of bugs, incorrect logic, or missing edge cases. LLM systems fail in different ways. They can hallucinate, misinterpret intent, ignore instructions, produce invalid format, or become vulnerable to prompt injection. That is why LLM systems need extra components. For example, they may need RAG for grounding, output validation, tool calling, guardrails, prompt testing, and human review for risky actions. Debugging is also harder. In traditional systems, we can inspect code paths, logs, metrics, and traces. In LLM systems, behavior depends on prompts, retrieved context, model version, tool results, and token limits. So we need to log prompts, context, outputs, tool calls, model version, latency, cost, and user feedback. Cost is another major difference. Traditional compute is usually cheaper and more predictable. LLM systems are more expensive because cost depends on model size, token count, context length, and number of calls. The key idea is this: LLM systems need stronger validation, observability, and cost control. In real production systems, the best answer is usually not a pure traditional system or a pure LLM system. The best answer is often hybrid. A common pattern is this: user input goes to the LLM. The LLM understands the user intent. Then the traditional system executes the business logic. After that, the LLM formats the response. Finally, the user receives the answer. For example, the user says, "Cancel my order." The LLM extracts the intent and order information. The backend validates rules and cancels the order. Then the LLM explains the result to the user. Here, the LLM handles language understanding and response generation. The traditional backend handles correctness, critical execution. This combines the strengths of both systems. The key idea is this: use LLMs for interpretation and generation. Use traditional systems for execution and guarantees. To summarize, traditional systems are deterministic, predictable, and easier to test. They are best for structured workflows and correctness-critical logic. LLM systems are probabilistic, flexible, and context-aware. They are best for natural language, unstructured data, and ambiguous tasks. The final insight is this: LLMs should complement traditional systems, not replace them. In most real systems, the best design is hybrid. Use LLMs for understanding and generation. Use traditional systems for execution and correctness. Thank you.